So we are a couple of minutes over time. So I will ask one quick question. Like, if I understand correctly, then this performance paradox is a feature of the matching policy rather than the graph. So if I design, instead of this first come first match policy, if I design the matching policy based on my graph, then is it possible to get rid of this performance paradox for all instances?
Yeah, I think so, because basically the intuition behind the paradox is that we should match all the neighbors of the bottleneck set with the bottleneck set, and by adding an edge between them, and if we match the neighbors together, this will bring a worse performance. So if you design your matching policy to prioritize the matching of the neighbors with the bottleneck set instead of matching them together, then I think that we could avoid the paradox in that case.
Thank you. So if there are like very quick questions, then please go ahead. Otherwise, we can of course follow up on Slack and offline. So,
exactly. Now, really, there is a break, right? Up to 5 p.m.
Yes.
Then
I have a question.
Go ahead.
Okay, so my question is like this way. I saw you use a stochastic model. What's the difference if we use this online matching model? Because it looks the same, because each time you say that each load arrive one by one, it look like an online model already. So can you slightly to explain what's the difference between the online model and your stochastic matching model?
Yeah, okay. So my understanding of the online model is that you are looking, for example, in bipartite compatibility graph, where you have one side which is fixed, and one side where it's stochastic, where you have queues and arrivals. And so the difference with the stochastic matching model is when both sides are stochastic. So you have the queues in both sides. But it's true that here it's on non-bipartite graphs, so it's a bit harder to make that distinction. But yeah, I think that would be the difference in my understanding.
As far as I know, I think, okay, online model is more care about the worst case. It's like because they try to say some adversary just act that give because you design something by probability, but this adversary will always output this online. I mean, this like 1-by-1 give the worst case. So it seems stochastic model is like adversary is not so powerful. They have the probability is given by your stochastic distribution, but for online model, somehow it's more worse. Maybe this is my understanding is difference of the two model.
Okay, well, I think that we are a bit over time, so
Okay,
maybe if you want to, we can continue this discussion.
Yeah, in the breakout rooms. Now we'll create. We'll put
as a question which I guess Rahul, you can ask directly to Arnaud in the breakout rooms.
Yes, exactly. Thank you.
Thank you. Thank you, everyone.